So we're going to look at arc length now, and it's going to be related back to your circumference, and then we're also going to look at area of a sector, which relates back to the area of the circle. So first of all, the thing I want to stress before we start is that arc length is different from an arc measure. So for example, if we use these two circles, I like this picture because it'll show you the difference between arc length and arc measure. So let's say we have a central angle. It's the central angle for both of these circles. And let's make it 90 degrees. So we now know the arc measure of that arc would be 90 degrees because it's the arc that the central angle intercepts. And we also know the arc measure of this bigger circle would still be 90 degrees. Both of those have the same arc measure because the measure is just in degrees. How much rotation was there? But arc length is something different. So if I trace the smaller arc with this red, the length of that arc, if I laid a string down on it to measure it, how long is that arc? That's clearly going to be different than the purple arc. This one's going to be larger, right? If I measured them with a string, it's going to take a longer piece of string to cover the purple arc. So that's what arc length is. It's the actual length in units, not degrees, in inches or centimeters or feet or miles. So you can see that the purple arc is going to be longer than the red arc. And that's what arc length is. So arc length is dependent upon how big the circle is, or the radius. So the way we're going to kind of look at this, so again, sorry, keep in mind that the arc measures of those two are the same, but their lengths are different. So the way we're going to think about finding the arc length is it's just a fraction or part of the circumference. Remember, if I use purple here, the circumference is really the perimeter. It's just a fancy word for perimeter of the circle. It's the distance all the way around the outside. Well, if I know, if I want to find the arc length of JK, just this part of the circle, we know that that's some fraction or part of the circumference. That's how we have to think of this. The way we're going to find JK, the green arc, its length, is we're just going to say that it's a fraction or a part of the entire circumference. So even though it's not the same thing as arc measure, we need arc measure to find it. We use arc measure to find out what fraction we're talking about. Since we say that the arc length is a fraction of the circumference, the arc measure will tell us what is that fraction. So let's look at these three circles, and you can pause the video here and draw them and ask yourself, try to figure out what fraction of the circle is each arc. Arc AB, arc CED, and arc EF. Pause the video and see if you can do that while you draw them. Okay, welcome back. So let's talk about these. Arc AB happened to be 1/4 of the circle. Now when I say the circle, that's sort of vague. It's 1/4 of the area. It's 1/4 of the circumference. It's just 1/4 of the circle. Any different kind of measurements I take of the circle, whether I take the measurement around the outside, which is circumference, that's what we're going to focus on. This would be 1/4 of the circumference, this arc AB, right? So this arc would be 1/4 of the entire circumference. On B, that arc CED was 1/2 of the circle. So that means its arc length would be 1/2 of the circumference. That length would be 1/2 of whatever the full distance around the outside is, which is circumference. And then EF would be 1/3 of the circle. So that arc length would be 1/3 of the circumference. By the way, how do we figure out these fractions if we don't just kind of know them or see them? Well, what you need is the arc measure. I know that arc measure is 90 because the central angle is 90 degrees. I know this arc measure is 180 because it's a semicircle. Or you can say that, the central angle is 180 degrees. So how do I come up with these fractions if you just don't know them? Well, you can take the 90 degrees, the arc measure, and divide by the total number of degrees in the entire circle. Right? So this arc measure was 180 divided by, there's 360 degrees in a circle. And this last one, 120, there's 360 degrees in a circle. So this reduces to 1/4, this reduces to 1/2, This reduces to 1/3. So if you're finding out what part of the circle, it's going to be the arc measure, not the length, the measure in degrees divided by 360, because that's how many degrees there are in the whole circle. So you can think of it as the part divided by the whole circle. The part divided by the whole. Or you're making a fraction. What fraction of the circle? All right, so now let's go ahead and find the length of an arc using this information. I need to know the arc measure, so I want to find the length of arc AB. Well, I know that that's 90 degrees because the central angle is 90 degrees. I also need to know the circumference. So here's how we're going to do this. I want to start with the fraction of the circle that arc is. It's 90 out of 360 because of the measure, right, in degrees. Is going to be equal to the arc length, the fraction, the part, over the entire circumference, which is 2 pi r. Right? We recall from the other video that circumference is 2 pi r. So I'm going to go 90 over 360 equals arc length over, now if I plug in my radius of 12, I get 24 pi. So if we solve this equation for arc length, we cross multiply. And I can cross multiply now, or I can reduce. I'm going to reduce. 1/4 equals L over 24 pi, and then this is going to go up here. So 24 pi times 1 is 24 pi, so we're doing our cross multiplication, times 4L. So then what we end up getting is we divide both sides by 4, and we get L equals 6 pi, and that was in meters. It's a length. Because my radius was given in meters, my answer is in meters. If you want to approximate, because you don't know how long 6 pi meters is, you can use 3.14 for pi, and that's going to be approximately 18.85 meters. That's the length of the arc. Keep in mind, its measure was 90 degrees, but now we have the length of that one. It's 18.85 meters because the radius was 12 meters. All right, now we want to find the arc length of, say, arc GH. So again, we take the arc measure of GH. Let me highlight this for you. We're looking for the arc length right here, this green length. So we take the arc measure and we make a fraction with that over its total circle in degrees. So remember, these are both the measures. It's the arc divided by the whole circle. We're doing the same thing over here, but now we're doing lengths. This is measure in degrees, this side. Whoops. Measure. This side is length. And in this case, it'll be in feet. So we do arc on top. We're making a proportion here. We don't know the arc length, so we call it L. And then we need the length of the entire circle on the bottom, which is known as circumference. So it's going to be 2 pi r. So the radius is 36, so 2 times 36, that gives me my 72 times pi. That's my circumference, okay? So you can do that on the side. Circumference equals 2 pi r, so circumference equals 2 pi times my radius. So I get circumference is 72 pi, and that's in feet. Whoops. So that's how I got the 72 pi. Remember, it's arc length over circumference. So I could reduce first, so that 140 over 360, I don't quite know how that reduces, but I could drop off a 0, so I'm too lazy to reduce that. I'll just reduce it all the way. I'll just stop there and say L over 72 pi. So now I cross multiply. I get 36L equals 14 times 72 is 1008 pi. So I'm going to divide both sides by 36, and I'm going to get 28 pi feet. That's the length of that arc. If you don't know how long that is, you can use 3.14 for pi. If you want to approximate, you'll get about 88 feet. So that's how you find arc length. The formula, if I were to give you a formula, would be the central angle A over the arc measure A over 360 equals arc length over circumference. That could sort of be your formula. Area of a sector is the same exact idea. To do the area of the sector, area of a sector means it's just the area of part of the circle. So we do the same thing. We do 60 over 360. That's the part of the circle that we want the area for. Equals, I'll make a ratio over here. This area, we'll just call it capital A for area of that shaded region, over the total area of the circle. So it's going to be 144 pi. because on the side, if I do the area of the circle, it's going to be pi r squared. So it's going to be pi times 12 squared. So it's going to be 144 pi. So now I cross multiply. I get 360a. Oh, we should probably reduce first. Sorry. So if I reduce first, I end up getting, what is that, 1/6? Yeah, 1/6 equals a over 144 pi. So then I cross multiply. I get 6 times the area equals 144 pi. I divide both sides by 6. And I get x, or area, equals 24 pi. And that's in centimeters squared because it's an area. So what you just did was, this represents the area of the entire circle. You just found what fraction of that area is this fraction of the circle. Again, using the idea that this is the fraction of the circle. So if the whole circle has an area of 144 pi, this part has an area, that's just a small fraction of it. That's about 1/6 of that area. And so that's how you find it. The area there is 24 pi. If you want to approximate it and get a decimal, 24 pi is about 75.4 centimeters squared. Let's do another example. What if you wanted to find the area of that portion of the circle? Well, if I know this arc is 45 degrees, the rest of it is 315 degrees because the entire circle is 360. So I need to use 315 over 360 because that's the part of the circle I have. It's almost the whole circle, right? That sets up my fraction of the circle. And now I'm just going to say A is the area of the shaded part, and I'm going to divide by the area of the whole circle. So keep in mind again this idea of the part of the circle is on top and the whole circle is on the bottom. Instead of circumference on the other side, we're doing it with areas. That's for the area of part of the circle. This is going to be the area of the whole circle. Okay, so we need to find the area of the whole circle. If the radius is 20 centimeters, pi 20 squared would be our area, so it would be 400 pi. All right, so now I'm going to reduce. This reduces to 1 over 8. If you can't reduce, you can just start cross multiplying right away. That's a pi. So now I cross multiply. I get 8a equals 400 pi. So a equals, I'm going to divide both sides by 8 and get 50 pi centimeters squared. Or, again, if you want the approximation, you multiply by 3.14. You get 157.08 centimeters squared.